Hello viewers, today for service and repair we have a Honeywell, I believe this is an 18-inch turbo VN. This one is completely DOA, no power whatsoever. Based on the condition of the cleanliness, I'd be willing to bet that the whole guard was blocked at some point and the thermal fuse went out. But there's really only one way to tell. So let's see what we can do. I wanted to work on this particular unit because this would be an excellent test for the dishwasher. Put all these, all the parts in there and just let it do its thing, and it should come out looking like new. So we have a lot of screws to remove. I kind of feel like this many screws is a bit much, especially for an all plastic apparatus. You can tell that somebody attempted to clean this at one point but did a terribly poor job. This thing was just completely filthy. More so than usual. This is not a standard amount of dust just from household use. I don't remember where this came from. I wonder if this is one of the fans I got from that garage. I really just don't remember. We even got like rusted screws and stuff going on here. So it's not locked up. In fact, the bearings seem to be in very good condition. So it's got to be either a busted up connection somewhere or a thermal fuse failure. I just noticed the blade is held on by one of these stupid little single-use crimp-on things. And that just caused me to lose a fair bit of respect for this model because I hate these things and I think they're dumb. A nut is a much better solution than this. These are very difficult to get off without breaking. I will try to do so, but these seldom go back on correctly even if you can get them off properly. Well, that came off fairly reasonably. As did that. Yeah, that's pretty bad. Very high hours. Well, nothing looks burnt in there. The windings appear to be of varying wire gauges, which is kind of interesting. I suppose we should start inside our switch compartment here, and let's see where the power is going, if any. We could get lucky and it's like a busted cord or something. Alright, so this is the line in. So let's we'll plug this in and we'll check for the presence of electricity. So we know that the cord is good. Doesn't seem like these wires are getting energized by the switch. What if the switch is busted? So it looks like this is the common and this is the high side. So that goes into line, which would make sense. And depending on which setting it's on, we should get power from each of these three leads. So we don't have any power going to the switch, and for some reason it seems like the high side goes into the motor first. So we gotta figure out why we're not getting any power into the switch. That's the first reason why it doesn't work. That's not what we want to undo. We want to undo this one. Oh, they stinking soldered this. I want to remove the motor from this housing so we can work on it easier, because we're going to have to split the motor open and figure out what's going on there. It doesn't technically matter which side is high and which side is common, because it's AC motor, it don't care. But for the purpose of electrical safety, the high side should go to the switch first, and then the common should be connected to the low side of the outlet. So we'll just take note that the textured side of the wire is the common. I'll go ahead and write that down. Alright, so we'll just, for the sake of ease, we'll just cut this as opposed to trying to unsolder it. And this motor is filthy. I'm going to go grab a little tarp thing to put down. Alright, so this is now free. I think I see what our problem is. Just put this off to the side for now. Still electrified. Alright, take a look at this. I wonder why it failed. I'm almost completely certain that we're going to have a thermal fuse blowout. That is ridiculous. Wow. I assume that there are vents under that cloud of dust which have not transferred any air in quite a few years. Yep. So this motor has been getting zero cooling through the vents here. And this is not regular household dust. This is very sticky almost. It's like shop dust. You know, it's got that grime to it. Wow. Okay. Yeah, that's really something. So, with that in mind, let's go ahead and open this up. I can't even identify what some of this stuff on the shaft is. I think I'm just going to cut it off. You know what likely would have prevented this is just a couple blasts with compressed air every now and again to keep the motor clean. Just a little bit of this thing called maintenance, which is a concept that seems to have vanished from society. A bunch of hair also wrapped around the shaft. Alright, I think that's all the contaminants from the shaft. Alright, now I need to get some thicker towels to clean the shaft with. Now it's handy when the machine is operable to be able to turn the motor on and clean the shaft with the help of the motion of the motor, but we don't have such benefit here, so we'll need to just clean this up by hand. I'll put a little bit of oil here on our thicker towel, and we'll try to get this as clean as possible because we're going to slide the bearing over this surface, and so we want it to be as clean and smooth as possible. Actually, you know what? Depending on how this is set up, okay, we'll scratch that. We will be able to clean it using the motion of the motor because the windings are going to be stuck to the back half of the shell, or so it appears because the wire is coming out there. So let's try to open this up, and then we can just leave the shaft in place with the front shell, and then once we get it to work, we'll clean it up and then slide it all the way out. Okay, that came apart much more easily than I was expecting. Alright, so this part we're just going to put that aside and we'll go back to that later. This is where we're going to have to do most of the work. So, unfortunately the thermal fuse is on the inside of the windings there on the other side, so we're going to have to remove the whole stator from the shell, and this is a process of extreme caution. We use the flat blade screwdriver to kind of pull up on the laminations, but we cannot scrape the windings, otherwise that's a whole different debacle, likely unsolvable. I can recover it the way it is now, most likely, but not if we damage the windings. And we have to use extreme caution with that coming out, because stuff's going to be brittle in here. Very brittle from the heat. Alright, we got it out. And as you can see, this was running so hot that the ties have just broken apart. So there's one tie that's kind of varnished in down here. If it comes out real easy, I'll take it off. If not, I'll just leave it. That came out pretty easy. Okay, so now this is where our thermal fuse likely resides, which is also where the problem likely resides. So if we trace this out, we have our high side. Let me just make sure this capacitor is discharged. This is our high side, which goes into motor, into this black wire here, and then what does this turn into? Turns into this other black wire, which then goes to the switch. So why the heck does it do that? That's kind of weird. I'm actually not seeing the thermal fuse, which is bizarre. Unless, is this it here? Oh, that's probably the, no, there's no, these are just the winding connectors. There's no thermal, oh, unless, could it be in here somewhere? Does this have a winding? Okay, it's got to be in here. Almost certainly it's got to be in here. Yep, there it is. There's our thermal fuse. If we take a multimeter and go across this, it almost certainly is going to be spoiled. Okay, so when we connect this end to here, we're likely to get no continuity. Okay, it's working. Open line. So that's our problem. Thermal fuse spoiled. Alright, so not a big deal. We'll get a new fuse. I should have some in stock here. This is a common part that we replace in this shop. Once I get this soldering iron plugged in, we're gonna we're gonna switch gears for a moment, and we're going to kind of brush some of the thick dust off outside, and then we'll put the rest of the parts in dishwasher. I think with the exception of this, that will leave out, but everything else, this can all go. The blade, nah, we're not going to put the blade in there either. Actually, we'll do the blade by hand because it doesn't take much effort. Clean the blade by hand. And then I'll take this base apart and we'll put the base in there as well, just so that that can all wash by itself and not waste my time. Now, I get some commentary on this channel about the editing, well, or the lack thereof, rather. This is an unedited video, as most of the videos are on this channel, and that seems to spark a lot of rage in some people. And I mean, that's, if you want to get upset over an unedited video, that's, I suppose you're entitled to do that. But you know, at the end of the day, you can sit here and watch over my shoulder as I work and learn how to do this for free, or not. That's up to you. I don't have time to edit videos, so either I bring it to you this way, or I can't bring it to you. That's why I don't edit videos. Alright, so we have everything that I need to fix this. We have, well, now they're all over the inside of the box here. I have commercial electric, flexible nylon cable ties. These are good for up to 185 degrees, which the motor should not operate at unless there's a problem. So these should be fine. Yes, these did fail. The motor also failed along with it. This is not the reason why the motor failed. Could you take the time to use the string that's on here instead? Absolutely, that's great. That's probably better. I'm going to use the cable ties. I don't have bad results personally with doing that. But there are definitely other ways to do it. Okay, thermal fuses, I hope I have some in stock. Okay, good, I do. So these are 115 degrees Celsius. The one that's in here is 115 degrees Celsius. That's usually what they are. And I'm not familiar enough with Celsius and Fahrenheit to tell you what it is in Fahrenheit. I'm sure there's a calculation that you can do if you want to know what that is. It's probably somewhere around 185 degrees, I would think. So we'll need that. We'll need one of these. And the connection apparatus is a little bit different on this. So we'll need to we'll have to figure out how we're going to fit this on here. I really should just order some more of this variety, because this is an inline fuse and this one is not. All we have to do is just strap it to the edge of the windings here. It's the same configuration more or less, but we got to figure out how to do that without any shorting. So we'll have to get some shrink tubing out as well, which is fine. I have some of that in stock also. And we need some solder. Okay. So here's our little motor mess. Let's get this heating up. I'll put some water on there in a minute. Alright, let's take the rest of the base apart. I think that the base will fill with water, so we need to remove the bottom part of it. Make sure your thermal fuses are nowhere near the soldering iron, otherwise you'll blow them out. Don't ask me how I know all about that. Okay, so what I'm actually just going to throw the whole cord in there too. There's no reason that the cord can't go in there. I'm trying to get these little, what do you call it, strain relief things out of there is a pain in the neck. It's an unnecessary hassle in this particular case. So this is what I was talking about here, this base. The fan is dated of 3/2006. So it was likely sold in the summer of, it could have been sold in the summer of 2006 if it was made in March. So this has got some age to it, but this was definitely used in some kind of harsh environment. It's just not normal amounts of dust in there. Oh, wash those by hand. The heat might degrade those things. And now we have more screws for some reason. Oh, you know what? Those screws might have just been for the feet. Well, that's fine. I wanted to take those off anyways. Okay, so now this can all just go into the, and the purple moon is that. Now all this can just go in the dishwasher and be cleaning up while we work on the motor. Got the parts loaded into the dishwasher. I rinsed this down in the sink just to get some of the thick air off. We're going to put the store brand dishwashing gel. And we're going to put some TSP into both the pre-wash and with the regular soap. We'll come back in a few hours to nice clean parts. While that washes, let's get into replacing this thermal fuse. So, we need to remove the existing fuse, which is spoiled. These are single-use fuses as opposed to the resetting switches that used to be used years ago. So we have to replace this now. We're going to want to use the smallest shrink tubing that I have. I don't need this much of a lead on here. We'll probably cut this in about half. Well, I guess it's bigger than 20 gauge. That's surprising to me. Let's try 18. Heck is this, some kind of non-strippable wire? What gives? That was weird. Everything in here is just singed from the extreme heat exposure. It definitely took a lot of hours off the motor's overall lifespan, but I wouldn't be surprised if we get a lot of use out of it still after we do this repair. I don't know why this wire does not strip easily. This is a little ridiculous. This piece of stuff here, don't really need that anymore, but we'll leave it there. Oh, this string tubing is too small. Alright, we'll have to go one size up. It's just going to end up fitting a little bit loose around the wires of the fuse itself. Okay. So we just need this to be long enough to cover the wire, the bare lead. Now everything here is heat activated. The solder, the shrink tube, and the fuse. So we have to work very quickly, because if we solder for too long, we blow the thermal fuse and we gotta start over again. We're not going for the nicest soldering job, we're going for speed here. So that's why this isn't looking the greatest, but it's fine. It'll serve the purpose. Alright, that's all we're going to do. Enough to secure it. Make sure we don't have any sharp points that will cut through the shrink tubing. Alright, now let's check it with our meter to make sure that we're good here. Okay, we're good. So the motor should be fixed at this point. Now I'm going to angle it like this so that the heat rises away from the fuse. And I'm going to try to get this to shrink just at the ends, just so that it secures around the wire. And that will just keep the tubing from moving down and exposing, you know, the bare wire here that could make a short. So that's good. The new fuse is installed, and now we can strap this back together. I want to clean the dust out of here before I put the new tie wraps on and wrap the wire in place. We will come back and do a much more thorough cleaning of this motor once I verify that it works, because I don't want to spend the time on it if it doesn't work. This could use a little bit of revarnishing. I might go grab the varnish and spray some on there once I get this tied down. Alright, so the way it was before, I guess it was all just kind of right here. This is a pretty delicate operation. This wire will break if you flex it too much. So ideally our thermal fuse will kind of go like this. We want to make sure that that's right up against the windings. A lot of connections here. I don't think there's a lot of slack to make them. Was this folded over like that? I don't remember. I don't remember how this was sitting in there. Some of these wires are really scorched from the heat. You can actually see the indentation of the windings on this wire here. That was getting really, really hot. But I think the insulation is still okay. It seems to be intact. I really don't know how much life this motor is going to have left after running that hot, but we'll see. The unfortunate part in this case is that it likely wasn't a a one-time deal. It was likely running very hot for a long time before finally some condition arose that caused it to exceed the threshold of what it could deem thermally acceptable. Alright, that should be good. I just realized that the power cord is in the dishwasher, so now I can't exactly test this. I'll have to just grab a different cord from something else. But that should fix it. Alright, so we'll come back and we'll clean and spray some varnish in a little while. Let's just verify first that this is now working. I think it will work. Oh, gosh. Snout check. Alright, so this needs to go in here straight, and it did not do that. It went in here totally crooked. Alright, let's see if we were able to salvage this motor or not. I gotta go get a power cord. Before we connect this to the electricity, let's check the ohms of the windings and make sure that we're getting reasonable readings as opposed to ones that would indicate some type of undesired operation. This is a 4 microfarads capacitor. On high we have 46, on medium we have 89, and on low we have 89 is 88. Those are pretty reasonable readings. 45, 74, and so I get the best connection 92. That's all pretty reasonable. You don't want to have anything to ground. Okay, that looks fine. Oh, I think we're good there. I don't think this will read properly because it's still hooked up, but let's see if it does. That's saying 0.3, which indicates that the capacitor is spoiled, but I think that's just because it's still hooked up to the windings. It is possible that the capacitor is spoiled and that's why the motor overheated. So if this still doesn't run properly, you know what, I've got the soldering iron on, or out still. We might as well just check this capacitor to make sure it's good, because it's possible that this has something to do with it. Jeez, it was only off for a couple seconds. There it goes. Capacitor reads 4.1, so the capacitor is probably still good. This check does not tell us the whole story because it doesn't test it under load, but if it's fine on there, it's probably okay. I'm almost 100% certain that the failure was dust, a heat-related issue. Where's that stupid little hole that this goes through? There it is. heck were these wire nuts from? Oh, these are the ones that was in the fan. We'll just reuse these in. Power factor is 0.99, power factor 0.96, power factor 0.8. It's a little low, but we are seeing the 99 on low, so that's actually now it's power factor 1. So I think the motor's okay. The amps and watts is totally irrelevant because there's no load on it. Alright, so that's working now. So now we can go ahead and clean the shaft off, so then we can give it a more proper cleanup. Okay, so now the shaft is smooth and clean, and we will be able to slide the bearing off of the front and give it a good clean. Oh man, this is a very sticky type of dust, and it's caused this to hold moisture up against here and become all rusty. So this is never going to look very nice again, but it'll work. And in this case, I'm much more interested in the functionality than the cosmetics. This is not a part of the fan that you can even see once it's assembled. There's an extra tie wrap there. Any other ones in here? No. See how that easily slid right off? That's what we wanted. Now we're going to polish the shaft. What is the problem here? Oh, it's kind of crooked, but we're going to go with it. Okay, that looks pretty good. Okay, the shaft is clean. It's been polished back to a mirror-like finish. It should run with very little friction now. These things are, well, they're a little bit yellowed from the heat, but it doesn't really matter because these don't move. They'd stay with the shaft. No friction on there. These two parts have friction though. So we'll clean these off. Oh, there's a bunch of washers here. What the heck? There's 3 of them. These definitely have some remnants of dried up oil on there. I'm surprised that the bearings were in as good a condition as they were on this thing with all the heat that they experienced. They're actually cleaning up really nice. These ones on the front probably had a little more airflow than the ones on the back. Come on, get over that lip. Stupid. Seriously, we go through all that and this is where the problem is? Good grief. This washer here is actually exhibiting a wear mark. See where it's worn down there. So I'm just going to put it back in backwards. It would be like a brand new one. Can't always get away with that, but in this particular scenario we can. This actually is spinning freely on here, so I'm going to stick some oil in there. We use the oil for fans. It's specifically for fans and lawnmowers too, as well as motors and some type of drill, I guess? I don't know. As opposed to the black can, which is for wrenches and bolts, hedge pruners, boots, power saw blades, and bicycles, not fans. Okay, shaft is good to go. Now for the bearings. Actually, they're not bad. We didn't really have any bearing issues to start with, so it shouldn't be that much of a surprise. This is a little bit more dirty back here. Considering how hot this was getting. That should be no surprise that the oil is all gummed up and dried out. Not bad in there either. Okay, so that's all clean. Now we're going to add some oil. We're going to put it in the space in between the bearing and the fan here. Not the fan, this part and in between. So just like in here, whatever you call these pieces, because there is a felt-like material in there which will absorb the oil and release it over time as needed. So we'll put a decent amount in there. Okay, and we'll do the same thing with this one as well. Doesn't seem like there's a whole lot of that material in there right now. I wonder if it's all just like deteriorated over the years. Alright, that looks pretty good to me. A couple extra drops in there for good measure, because they'll stay in there because the bearing is not open on the other side. I'm going to go grab some varnishing spray. We'll spray a couple parts and then we'll close the motor back up. In a perfect world, we would wash the windings with a liquid cleaning, rinse everything out, and then dry it for a while with a low current. Spray the varnish all over and then dry it out with a low current, heat from low current again. But this is not a perfect world, nor is this a rare valuable piece. It's just a fairly run-of-the-mill fan from 20 years ago. So we're just going to spray some varnish on the spots that I messed with to grab any oh man, I just got old junk in there, just to get any loose pieces tied down, and that's good enough. A couple spots I see loose wires, like right here. That's a loose wire, so we'll spray there. That's it. That's all we're gonna do. That varnish really should be sprayed outside. Gosh, I might have to take a break and let the studio air out. Getting high on EL 600 varnish in here. Good grief. I'll put this in. I've done this in the house plenty of times. This is the worst it's ever been. It's not usually like this. Well, things are looking a lot better for this motor now. A lot better than they were a couple hours ago. So we're going to put this back together now. Just put a little bit of oil. Oil gets everywhere. We'll put we'll put a little bit of oil on the shaft here. Drop this in place. There's like an air bubble that you'll have to overcome. Look at that glide. These bearings are pretty good. Alright, and we'll put a little bit of oil on the other side as well. I don't think that this is, I don't think any of this is, oh, this has an oil port on it. That's cool. That's neat. I didn't know that this had oil ports. So we want to line up the oil ports so that they're both at the top. I'm surprised this has oil ports being from 2006. That has certainly passed the era of very good quality motors. I think we can put away the our tarp now. Shouldn't be anything too crazy in terms of dirt anymore. I started using these a lot recently. These are bags that the heating pellets come in, and I've always saved them because I figured they'd be good for something. I used to use them for just like the trash can liners and stuff, but now I've been using them for all sorts of stuff. So, for routine service, all we have to do to oil it is just put some oil in this little hole here, and that will lubricate, or that will put oil onto that wick material. Now we already did this, so it's kind of pointless to do it again. I already did it from the inside manually, but this is the concept that you would execute. Very surprised to see that. Not expecting that at all. So unlike the front, the back one here is still taking oil in, so we'll keep putting it as much as it wants. Alright, that should be good. I think that the material on the front has disintegrated because it should be taking oil in and it's not. Well, that's it. It doesn't matter because I oiled it inside anyways. Let's wipe off any excess so we don't have a mess here. Wow. The little motor's ready to go again. What a terrible abuse of the equipment. These must have been halfway decent motors, at least to have the oil ports and to have survived as long as it did with practically no cooling, because that amount of dust does not build up overnight. In fact, I'd be willing to bet that it probably was running for years with that much dust, and then there was just some particular occurrence. I don't know if maybe it was an exceptionally hot day and the fan was placed in the sun, or if something got up against the back of the fan and cut off the airflow, or whatever the reasoning was. I'd be willing to bet there was an additional event that transpired that ultimately caused the failure. Why this is not going in properly. The other ones went in pretty good. Well, this might last another 10,000 hours. It might break tomorrow. Who knows? Now to align the bearings, these are self-aligning bearings. We just take a screwdriver and kind of tap on the shaft a little bit, moving this in and out. Can move it around. Look at that. Running good as new. Alright. I don't see any reason why it wouldn't still be working, but let's just verify. I would say we don't want a callback, but I'm I'm the customer, so I'm going to call myself and say it still doesn't work. But it is true, you never want to call back. Always check stuff and make sure it's right before it goes back. Always. Okay, that's off. High. Medium. Low. We are 100% operational and ready to go back in the fan. There's some pretty dirty water coming out of that dishwasher, so hopefully it is working as well as it has on other projects, and we'll get a like new looking component. Alright, so we need to clean this knob out, and we got to clean the blades. So let's go over to the cleaning area. We'll clean this stuff up, and hopefully the dishwasher will be done soon. It's a newer one, so it takes some time to complete a cycle, but it's been running for at least an hour or two now, so it should be getting towards the end. I don't know what these things are called, but I should really order some new ones to have on hand, because there's a bunch of respectable fans that I work on often which end up having these stupid things, and they're always a problem. I wish there was some kind of better alternative. You know what? Actually, might be a good alternative is just a tie wrap put on real tight. That might be a better alternative than this. I really don't like these. Here we are at the cleaning area. The dishwasher is still running. I should really take note of how long the cycle takes. I don't care, it can take as long as it wants because it works great, but it'd be nice to know just for planning and organization purposes. Alright, I have one piece of melamine foam here already, which should be enough for this project. Not in the best of condition here, but we're only cleaning one blade. It should last long enough for that. The heck? This really is like a miracle product. It's just unbelievable how well it works. And it's very consistent too. It consistently works very well. What the heck is up with that? Did you hear that? It sounded like that thing just shut on and it shut right back off. Jeez, I hope it didn't just break. I don't know what would have been calling for hot water. The dishwasher, I don't think, is taking in any water at this point in the cycle. I need that small brush. Yeah, I think that this was used in like a garage or shop environment. And if I recall correctly, I bought this at it was actually a really cool sale. I remember it pretty vividly. I went, might have been last year or the year before last year. And going on my birthday, I just went out looking for tag sales or whatever, and I found this big sale at a, I don't know what the business was, but it was like a huge garage. It had just tons of stuff, like a whole mess of fans. And I'm pretty sure that this was one of them. They were all pretty grimy. Most of them were actually ones that I like. So I bought a lot of fans there. And I bet this was one of the ones that they had used in the area. Because this is like greasy, like machine grease type stuff on here. It's not regular household dust. Just a point of interest here to see how dirty this got. I mean, how hot it got. This actually melted. This part and that part melted from the heat. Actually, several of these are melted and deformed from the heat. That's how hot it was getting for a while. Not good. We're going to have to put some soap in here as this is not coming out. That poor motor was scorching hot. Holy mackerel. I can't believe, I didn't realize this was actually melted inside. Oh, it just goes to show that the 2000s era products, although, you know, they were definitely starting to get really cheap and a lot of them were not as good as they should have been, there was still some stuff that was reasonably well built. These weren't the cheapest fans at the time. I would say these were at least mid-grade. I'm pretty sure there is still a variant of this made to this day. I think these are very loud. And so, although it would be interesting to buy one to compare, it probably would be a waste of money because I think it's probably going to be too loud for me to want to use it. I don't know how much use I'll actually get out of this one. Now that I live here, and I have the garage and I have the living room, which are two very large spaces, I find that I use larger, louder fans without issue. So maybe I will get a lot of use out of this, I don't know. I'm also not sure how much use it'll give. You know, it might keep running. It might keep running for a long time. Actually, I think there's a good chance it will. This has some paint splatter on it, and the melamine foam did not seem to take it off. Looks like there's still some grime on the tips of these blades. This is taking it off, but it's taking some extra time. I'm very curious to see how the dishwasher handles this type of grime. It would have taken hours to clean that guard off by hand. I'm really hoping that we don't have to. Oh, this is not removing the paint splatter. I'm a little surprised. I thought it might. I haven't run into much this doesn't remove. I actually bought a hanging thing today, but of course it's not. It's upstairs, which isn't very helpful. It needs to be down here on the sink. Well, that's pretty clean. Looks like this blade could use a little bit more cleaning on the trailing edge here. I can see why you shouldn't use this on the translucent blade fans. I can even see the haze it created on this. Doesn't matter on this particular blade, but I would be upset if that happened to a translucent blade. I don't know if these blades are starting to warp or if they were always like this, but this is not straight anymore. It's kind of like that. It doesn't seem like it would affect the airflow, but I just don't know if that's the way it was originally supposed to be or not. It looks like something collided with this at one point. Maybe somebody took this off previously and put it down like that. I don't know. A ring of marks around there. So this switch is this is a push to turn knob, which is kind of interesting. So I didn't want to put it in the dishwasher because I don't know what's inside this and how this works. So we'll just rinse it off by hand. Alright, now we just wait for the dishwasher to finish and then reassemble. Reassembly should go pretty quick, I would think. This did not clean up quite as well as some of the other things we've put into the dishwasher, but this was not typical. Whatever environment this was used in was exceptionally dirty, with very sticky dirt. As far as household dust is concerned, I think the dishwasher is pretty much 100% with. This was like maybe 80 or 90%. If you really wanted to get all this, whatever this is off of there, I think you're looking at a good old-fashioned sit there and scrub each and every slat with some type of brush. At least for this particular project, I just have other things I'd rather do with my time. This is good enough. I don't think that, whatever is still on there, if it didn't come off in the dishwasher, I really don't feel like it's going to be, coming off into the air and making toxic whatever into the house. So, let's get the water out of these screw holes. Now whatever residuals water is in here, it'll just dry out, within the first few minutes of the operation of the fan. I'm not concerned about it. Well, this motor was definitely quite the transformation. This is what it's it's not quite what it's supposed to look like. It's supposed to look like that, but at least now the windings will get air through it and run at a reasonable temperature, unlike before. A little bit too much oil leaking out there. How long this will last, I don't know. Higher temperature definitely reduces the life of the motor, but hopefully it didn't run like that for too long and it's got plenty of life left in it. According to our note here, the textured side of the cord is the common, so that would be this side. So this will go on here. Okay. The wire just broke. This moret just spoiled. We're going to replace these. These don't have many metal inside. They're just all plastic. I don't feel like those make a good connection. And this is, an all plastic appliance. This is definitely one of those things that you do not want a connection heating up inside. We saw what happened with the blade up against the motor like that, how hot and deformed that plastic became. It's not good. I don't like all these plastic appliances, you know, containing electrical connections. Well, that just broke. And this Mirette is now spoiled. Closing out with some trouble here. Sometimes that happens. I just hope the lead wires don't become too short now. I'm surprised those kept breaking. This is stranded wire. Usually that happens with solid wire. I recall correctly, this capacitor was not held in place. It was just kind of chilling there. Same thing with the with the switch. The switch, I at least can see how it stays in place when you close it. The capacitor, I don't see it. Is that really it? It really just sits there like that? That's kind of crazy. Okay. Yeah, lead wires are getting pretty short here, but they're good enough still. Just barely. A little too much oil there. Well, that would have been helpful if it was charged up. Okay, that's ridiculous. I'll just charge it up. Craft Tech. Had this little thing for a long time. My uncle gave this to me many years ago. I've only changed the battery once. It still works fine as long as it's charged up. These screws really are a bit excessive in length. I think like a 1/2-inch screw would have been just fine. Something just fell. Fan blade. For a fan that actually I think has the same problem as this one did. Oh, where's that piece that goes over the thing? I am never using this unattended. The way this is set up is just crazy. You have all this. You have a capacitor with open leads just touching all the wires. This barely reaches, although that might be because of the fact we had to cut it. And all this is just inside a piece of plastic. That's insanity to me. Not the way it should be set up. Should all be encased in metal, and everything should have its own. The capacitor should be in its own piece of metal. The switch should be inside a piece of metal. The switch should be metal, and it should all be grounded. That's the way it was. That's the way it goes back, but it's insane.
This would have closed easier if it wasn't for the fact that the lead wires became so short from the repair. And that's the only reason that we're having a problem with this, is because of the cuts made in the wires. I think I got it now. I don't like that this piece goes down and pushes on certain wires. That's pretty stupid too. Trying to organize this the best I can before we shut it then. I think that's okay. It's not the best, but I think it's safe. As safe as this will be. Doesn't seem like it's pinching any of the wires. That was my concern. Yeah, that's good like that. I hate it, but that's the way it is. That's the way it was. That's the way it goes back. Would not have done it like that. I would have designed this area very differently if I was making the fee-in. Oh, had a 50-50 shot and I got it backwards. The switch needs to be turned around. So now I have to undo everything I just did and try again. Not a big deal. it lines up with the numbers. Alright, let's power this on and make sure that it works before we patch it back up the rest of the way. Seems to be working. Is this wrong? No. It's definitely the way it's supposed to go. I don't know why the base is all cockamamie now. Maybe the plastic's slightly expanded or something in the machine. After all, these fans are not technically dishwasher safe. Well, I'd say those bearings are quite content. It does seem like this is going to be kind of a noisy fan though. I forgot to put that washer back on. That could potentially be a problem. The oil port is not up. I would have preferred it to be up there, but whatever. I mean, you can't reach the back one without taking the motor off anyway, so I guess it's inconsequential. Put this stupid piece of garbage back on. Actually, that held pretty good. That one came off and went back on all right. Well, the bearings are definitely ready for some more hours. The motor itself, well, time will tell. I think it's fine. The windings don't look bad at all. Here's the second part where I really wish I had that electric screwdriver. Yeah, this could be cleaned up further. It would require a manual scrubbing of each slat. Okay, there we go. The tilt adjustment is not working properly, but we'll just tighten this down and call it a day. It looks like somebody else has tightened it in the past because the screw is totally stripped out and I didn't do that. Okay, well, that's quite the transformation, even though it's not the best cosmetic thing I've ever seen. It should certainly work now. Yep, that is a pretty loud fan. But at least it is pretty powerful. Actually, that's quite powerful. I didn't think it was going to be that strong. That is at 116.8 volts, 0.63 the amps, 73 the watts, with a power factor of 1. What is this rated for? It is rated for 1.2 amps. Not a big difference in speeds. The blade is in pretty good balance. That's 0.72 amps, 84 the watts, and power factor 0.99. I can feel this clear across the room. This is pretty strong. The air travels very well. It's not like a super fast velocity air, but it carries very well. I think that's reasonable. Decent jump on high from medium. So that's only 0.88 amps, which is quite a ways away from 1.2. And the wattage is 96 watts. The power factor is 0.93 the power factor. Yeah, the balance is reasonable. I wouldn't even try to make it any better. It's good enough. For the air being moved, it's not that loud. It's loud, but it's moving a lot of air. This would probably be fine in the living room or in the garage. I kind of like it. Noisier, but I think for the air it moves, the noise is definitely acceptable. I will say the same thing I said about all the other Honeywell fans that use this blade set though. If you increase the blade pitch, which you clearly could because the motor is not even drawing the amount of power it's rated at. If you increase the blade pitch and slowed it down, you get the same amount of air with less noise. I guess it's not that loud. You have to keep in mind too, down here it's dead silent. There's nothing running down here. No pellet stoves, no dehumidifiers right now, no other fans. So the fans, when we're testing them down here, they seem louder than if you was using them somewhere else. See what the inrush is. The kilowatt meter doesn't really give a good capturing of the inrush, but 1.03 was the highest I saw. Alright, well, I think this should be good for many more hours of operation. Now that the you can kind of see, the blade didn't stop at the best spot, but you can see right through the back. It clearly pulls plenty of air through the motor, although I will say that the area on the guard where the motor is, this is pretty thick, and that's not going to let through a whole lot of air to begin with. And that I don't see why that wouldn't have just been this pattern. You know, that's definitely blocking a lot of air. And of course the same thing with the dust. Now granted it's much easier just for the average user just to wipe this off, but the dust will plug up these little holes very quickly. Wow. That was really something. I like cleanups like this where it's just really outrageous and then you can get everything to work again.